This video will cover the study guide for exam number 1 for Stat 210 in the fall 2023 semester. Okay, let's go ahead and get started then. So as we talked about in class, exam number 1 is going to be on Monday, October 2nd. And this exam will cover handouts 1 through 5. And then also quizzes number 1 through 5 are relevant for exam number 1 here. Okay, so let's get to the study guide. The first question here is a case about discrimination. We know that 34% of the candidates for the head coaching position were African American. They looked at the hiring of 18 coaches, of which 2 were African American. So the number line here is going to go from 0 up to 18. The reference distribution is going to be set at that 34%. So we build that reference distribution under what it would look like if hiring was fair or there was no discrimination. So that's going to be centered here at 6.12 is going to be my expected. Simply take 18 times that 34% to get the expected. And here, obviously, the parameter value there is that 34%. I do ask for a label here, and again, the labeling is just what we're keeping track of, which is the number of African Americans. So that would be the correct label. The next is just about how to set this reference distribution up in StatKey. Sample size is just the maximum number on the number line, so that's going to be 18. The null hypothesis value there is that 34%, or our parameter value for the problem. I went ahead and gave you the simulated outcomes here, 100 trials of a simulation, so there's 100 dots on that picture. The reference distribution was obtained under the assumption that bias was occurring. No, that's false. The reference distribution is obtained under an unbiased situation where there's no discrimination. The next one is true. That's fairly straightforward. This one here, C, is just asking you about the decision there. So using the 5% rule, the observed result of 2, which 2 is an outlier on this lower end. So this is a left-tailed analysis. If we go back up to the research question, they want to know, is there evidence to suggest racial discrimination had occurred in the hiring of African Americans? And if there was discrimination occurring then against African Americans, then there would be too few being hired here. So it's going to be a left-sided analysis for this one. So let's go back to C here, 3C. So using a 5% rule, the observed outcome of 2, which is going to be an outlier on that lower end. Okay. So it is 2 is an outlier on that lower end. So we are going to have enough evidence to say that there's racial discrimination against African Americans. Okay, so that statement is true there. D is false. That is just where the expected, so 5, 6, and 7 are kind of middle of the distribution here. And those are values that we would expect if discrimination was not happening, or a fair situation. This one here sometimes throws you off a little bit because I went ahead and computed the 2 out of the 18, which is 11%. But that is not the p-value. The p-value for this problem is going to be counting the number of dots at 2 or less if it's left-tailed. So let's go back up here. The study outcome is at 2. So if I were to ask what is the p-value for this problem, it's going to be 2 dots out of the 100 total. So our p-value for this problem would be 0.02. Okay, but just taking 2 divided by 18 or finding the percentage there is not the p-value. So this is just garbage down here, so this statement is false. Okay, let's move on to the next one. I believe your 1 in 5 test, we actually saw that on one of your quizzes, I think it was. So that one reappeared, but in a different form here. So this is, they had to recall an additional letter, recall a letter that was on the previous card. And there's a good chance they're going to be able to do that because 4 out of the 5 letters were on the previous card. So the proportion of getting a correct outcome is going to be 80% in this situation. So identify the appropriate setup of the reference distribution here. There's only 12 trials going on here. So this is 12 is going to be the maximum, 0 is going to be the minimum. We're tracking the number of correct, and then the 80% up the number line is where I'm going to have my reference distribution. Now this has a pretty compact number line, so we might end up having a little bit truncated off here on the right side. We're not going to worry too much about that. In fact, here we care about the left side, okay, because we are going to try, well, we'll wait for that. That's coming up. Likewise, the setup here is sample size is going to be 12. The proportion is 80%. Here, number 6, how many of the 12 trials do you expect a patient to answer correctly if they truly suffer from memory loss? So that is just going to be that expected count here. That's what that 80% implies up here. If they have an 80% chance of getting it correct, just because 4 of the 5 were already on that card. Okay. Here's what that distribution looks like. So this one is about, somebody came up with a rule that says 5 out of the 12 would suggest that they are faking their memory loss. So this is asking about faking their memory loss. We don't want to use that edge of the distribution. We started the first couple of examples, like maybe that would work to use the edge of the distribution, and then we quickly moved to the 5% rule. The reason we don't want to use the edge of the distribution is because if I get more dots, then that boundary on that left side is going to keep going down and down and down, right? So we certainly don't want the boundary or my cutoff value to be dependent on how many dots I'm using for my simulated outcomes. So that's what this part A is about. Part B is then just find me the appropriate cutoff value for this distribution right here. I believe there's 100 dots on here again, so 6 looks like it'll work. That'll be about 0.02, right? 2 out of 100. If I go up to 7, then I'm going to have 1, 2, 3, 4, 5, 6, 7. 7 would have an error rate of 7 out of 100, or 7%, which is a little bit high. So I would advocate as a statistician of using 6 as a cutoff. Again, I would let you use 7 just so the rationale was provided. If you did say, well, I'm going to use 7 because I think an error rate of 7% is okay, then I would go ahead and count that correct for B. Okay, let's get into our multiple choice now. This is about people with a medical condition here, HFM. We took information from 86 patients, so that is going to be my sample size here. Looks like the study outcome is at 14. So, and 10% of the people are left-handed in this situation. So if I ask about the parameter, that's going to be 10%. Question number 7 says, what is the scope of inference? That is going to be those diagnosed with this condition, not the 86. I'm going to have some of you put down 86 here. That is the sample, the data that we collected. The scope of inference talks about who are we trying to make inferences about or decisions about, and it's those with this HFM condition and their left-handedness rate. Okay, so C is not the right answer there, B is. Question 8, that's hopefully straightforward. N is equal to 86 and my parameter is at 10. Do not say that the parameter value is 16, because then you would be using the sanitizer bottle idea to compute what our parameter is. So 14 here is the sanitizer bottle that does not get used in the construction of the reference distribution. It does get used if you're computing the p-value, okay, but not in the construction of the reference distribution. Here I'm giving you the p-value and just asking you what is your decision going to be here. Again, if that p-value is less than 0.05, then you have enough evidence. And if it's not less than 0.05, then we do not have enough evidence. So the correct one here is going to be B. Make sure it has the 3 parts, right? The conclusion has the 3 parts, does not provide enough evidence. Then we have the research question, that's the second part, and then it has the p-value components, that's the third part. If I leave the p-value component off, then that's not going to be a completely correct conclusion. Okay, just some more multiple choice questions. This is going to be a 50-50 scenario. Excuse me, this is going to be a 50-50 scenario here for number 10. Number 11, giving you a p-value where I'm less than 0.05 here. So this time I do have enough evidence. And here, this is a, can I tell the difference between the two of them? Some of you will say that B is also correct. We don't want to say just because they got more than what we expect, that implies we have enough evidence. So B is not correct. We've really got to base these decisions solely on the p-value. So C is the correct answer there. Number 12 is just, do you understand what the p-value is? And again, if your friend is just guessing, they have a 50-50 chance of getting it right. There's a 3.5% chance that you're going to get 7 or more correct. So C is the correct answer there. 13 is just setting up, how would you set up the reference distribution? So you'd set it up under a 50-50 and then calculate the proportion of times that 4 or more are correct. So again, more on just how do you get the p-value for a given situation. 14 is just a little bit, so I got one question here about setting up the null and alternative. If this was worth maybe 4 points, this would probably be worth, the definition of the parameter is probably the most important part in here. But again, just can you tell me what the H0 and the HA is? And then the parameter, this is probably worth 1 point here, something like just setting it up in terms of the, like we statisticians do. So yeah, a little bit on that. I think I only had one problem on this exam. Not going to be, I'll leave it as that. Another one with the p-value less than 0.05. So we're hitting that pretty hard on this exam. Not necessarily going to be the case on your exam. It just turns out that I had 3 questions, I think it's so far just on the conclusions. So that's less than 0.05, so we do have enough evidence here. This one is about with another p-value. So it's not necessarily just, do you know when you would have enough evidence or not? So really this one's more about the decision, because we're trying to, this p-value does not provide enough evidence because the p-value is large. Some of you are going to say, you get that backwards. If the p-value is small, then I have enough evidence. You're trying to remember all this stuff, sometimes that you would get backwards on that. So this is really more just about a decision. Number 16 there. 17 is just, do you understand what a p-value is again? Again, it's results as extreme or more extreme. Okay, so if you go back and look at the definition of a p-value, it's outcomes that are as extreme or more extreme. Here's a question about the margin of error here, number 19. So here is the margin of error formula. N is in the denominator. If n gets really, really big, then my margin of error is going to be going down. Not up, but down. So B is the correct answer there. This one sometimes will trip up people. What goes into the formula, so number 20 here, what goes into the formula here is the number of people that you sampled. It does not depend on the number of people in the population or in your scope of inference. So if my scope of inference was Winona residents and I sampled 800 people, that's going to give me, I guess I tell you, that's going to give me a margin of error of about 3.5%. If my scope of inference now includes all of Minnesota, but I still want a margin of error of 3.5%, again, all that matters is how many you actually put in your sample. So I only need 800 again. This formula does not take into consideration how big is your scope of inference. That does not play into this. So again, the correct answer here for number 20 is just going to be about 800. It's going to be about the same. Because again, that's what goes into that margin of error formula. I'm going to skip over number 21 and 22. I'll let you just try to figure that out. It's a hacking situation where we know that 4 heads are always going to come up, and then these 8 over here are actually fair coins. So they're going to flip a fair coin 8 times. And what I'm interested in is the number of heads in total. So it's a little variation on kind of what we've been doing in terms of setting up our reference distributions. But I'll let you work on number 21 and 22. The answers are provided there, but I'll let you think through why that's the case. Okay, the last one then, the point for which we start to believe that the outcome is an outlier, well, that's always going to be on the edge of the distribution. It's either going to be on the high side or the low side. If I'm doing a one-tailed problem and I have 5% error, then that cutoff is either going to be the top 5% for a right-sided analysis, or it's going to be the bottom 5% for the left-side analysis. So that's true. A parameter is required to build a reference distribution. Yep, 100%. We need that. We need that pi value. That's what goes into the app, or what we, if we're using the binomial formulas inside a JMP, then I need that value. The p-value is computed by determining the portion of dots that are as extreme or more extreme. Yep, so that's just the definition of the p-value there coming through on that true-false. We need to know the study outcome before building a reference distribution. Hopefully that's makes sense to everybody that that's false, because the study value is my sanitizer value, and that is not used when building a reference distribution for testing. We do use it for building a reference distribution for the margin of error calculations, but in general we do not. The binomial probability distribution has no assumptions. That's false. The binomial, right, has two outcomes. They need the same probability of success. There's a fixed number of trials. And I think the other one is the trials need to be independent of one another, I believe is the last one. So there are some conditions or assumptions that we need for the binomial to work. Okay, that's a quick review of the solutions here for study guide number 1 for the fall of 2023. Good luck with your studying, and we will see you on Monday. Thank you.